This is lesson 6.4, partial factoring and completing the square. Before we get into this, I just want to do a quick recap of everything, well, not of everything that we've done, but just take a look at the different forms. So far we've looked at standard form, which is y equals ax squared plus bx plus c. And then we've looked at factored form. So you take standard form and you factor it so that you can figure out what the x-intercepts are. And once it's factored, you get x minus r and x minus s, or there might be some some coefficients in front of the x's, which is okay. We've learned how to deal with that. And then finally, we have what's called vertex form, which we use to do transformations, so shifting it left and right, shifting it up and down, figuring out what the stretch or compression factor is, or if it's opening up or opening down. And that was y equals a x minus r squared. Sorry, that's wrong. It's x minus h squared plus k. So x and y are the two variables that you're trying to find the relationship between. So the x is the variable on the horizontal axis, that's your independent variable. The y is the variable on the vertical axis, which is your dependent variable. And then a, b, c, r, s, h, and k are all what we call parameters, which just tell us something about that parabola. It tells us something about the relationship. We know it's a quadratic, so graphically speaking, we know that it's a parabolic shape. The graph would be a parabolic shape, but then all of those parameters tell you something about that shape and where it occurs on the graph. The c value, remember, is your y-intercept if it's in standard form. If it's in factored form, R and S, or sometimes you have to, like sometimes this one looks like this, y equals, I'm just going to use let's say, I'm going to use P. So px minus R and qx minus S. That can be that is the same as this sort of. It's just a little bit more complicated version of it, because sometimes, remember, after you factored, especially if you have a complex trinomial, you sometimes get a coefficient on the x in either one or both of the equations. So technically, really, the x-intercepts would be r over p and s over q. But when we talk about it in general terms, we just have x minus r and x minus s. And so the x-intercepts are r and s. Okay, so this would be a more complicated version of it when you are dealing with a complex trinomial. And remember, you had to take px minus r and let it equal 0. So that x would be bringing the r over, makes it a positive r, and then dividing by p. And then you'd have to do qx minus s. That would also have to equal 0. Bring the s over, that makes it a positive s, and then divided by q to isolate the x, to figure out what the x-intercepts are. Okay, just a more complicated version of the same thing. And for vertex form, we have y equals a x minus h squared plus k. And the h and the k tell you what the vertex is. So if you're in factored form, you can't figure out what the y-intercept is without letting x equal 0. You can't look at the last number and say, oh, that's the y-intercept, because it's not. If you're in vertex form, you can't look at the k and say the very last number in the equation and say, oh, that's the y-intercept. It's not. So you have to be able to identify which version of the equation that you're in, so that you know what that equation is telling you about the relationship between x and y. So now the a value, remember, that's telling you about the direction of the opening. So is it opening up or down? If a is positive, it opens up. If a is negative, it opens down. And it also tells you about the the compression or stretch factor. So is it a wide parabola? Is it a narrow parabola? The A value in vertex form will be the same as the A value in factored form, which is the same as the A value in standard form. We never look at this B. We never look at it because graphically speaking, it's really not telling us much. You don't look at it this year. You don't look at it next year. You don't look at it in grade 12. You never consider the B. It's got to be there. It's necessary. It has a purpose, but we don't ever really study it. Okay, so up to this point, we have been able to go from standard to factored. We have been able to get to vertex from standard via factored, so we'd have to factor it first and then go to vertex form. What we want to be able to do is we want to go from standard to vertex form. And that's what this lesson is all about, is how do we do that? Because not all quadratic relationships have a factored form. Remember, factored form is telling us what the x-intercepts are. What if you have a parabola that opens up and it is not touching the x-axis at all? That means there are no x-intercepts, which means there is no factored form for that particular parabola. Or what if it does touch the x-axis, but these numbers are not really easy to figure out? Like, let's say they are like square roots, or like they might be root 3, or they could be 2 plus root 5 over 7. Like, who knows? They're not easily factorable, or just not factorable at all. So we have those situations. Every parabola has a vertex, which means every parabola has a vertex form. But not every parabola has a factored form, because not every parabola has x-intercepts, and not every parabola has easy or friendly x-intercepts. Some of them are pretty complicated. So we can't always get to vertex form by going through factored form. So we need a way to get to vertex form. And again, why do we even want to get to vertex form? We want to get to vertex form so that we can figure out what the vertex is. Because looking at standard form, you can't do anything. And of course, all of this is based on the fact that maybe we don't have technology and we're doing these things algebraically. And these are good algebraic exercises to be able to do. So let's take a look at this first example that I have here. Suppose a quadratic relation is in standard form. Up to now, we have been able to determine the vertex if we are able to factor it, then average the zeros, and so on. So for example, this is what we've been able to do. This one is a complex trinomial, which means we're going to have to use decomposition. That 3 out in front, it's not a common factor between all 3 of the terms, which means it can't just be factored out. So the only option is decomposition. There is another way of doing it, which I haven't taught you, and some of you might have done a little bit of research on how to do this, or you might have talked to your older siblings on how to do this. I will, maybe in the last week of June, give you other options. You still need to know how to do decomposition for next year and after that. But there is another way to do this, and I will show it to you later. We just don't have all the time in the world, and I still have some things to teach you. So, and decomposition always works if it's factorable, okay? And we're going to look later on how to determine if it's factorable in the first place, but not in this lesson. We'll do it in another lesson. Okay, so decomposition. So we are looking to find 2 numbers that multiply to give you -6, because 3 times -2 is -6, and they add to give you -5. And those 2 numbers are going to be -6 and +1. So with decomposition, we have to break that middle term up into those 2 values. And then we factor by grouping. So you common factor the first two, common factor the second two. So the common factor with the first two terms is 3x, and you're left with an x minus 2. And the common factor with the second two terms is just 1. There's nothing else that goes into those terms, just 1 does. And you're still left with the x minus 2. So then you common factor between all of this and all of this, and they have an x plus 2 in common, and you're also left with a 3x plus 1. Now, normally we would now find where the x-intercepts are, and to find the x-intercepts, let y equal 0. So 0 equals x plus 2 times 3x plus 1. And for that to equal 0, either this bracket equals 0 or that bracket equals 0. You might have remembered the pattern that happens, but if you don't, you can just set those brackets equal to 0 and solve for x. So then 3x plus 1 equals 0. Bring the 1 over, that's a negative 1. Divide both sides by 3, and you get x equals negative 1/3. So what we know about this parabola at this point is that its y-intercept is negative 2. I'm just going to draw a little. So y-intercept is at negative 2, and it is, oh sorry, this should be an x minus 2. Let me fix that. Wonder if any of you caught that. Did any of you catch that? Okay, so this should be an x minus 2, and so this should be an x minus 2 equals 0, which is x equals 2. So we've got an x-intercept at 2, and we've got another x-intercept at negative 1/3. It's crossing the y-axis at 2, and we know that the axis of symmetry is somewhere in between negative 1/3 and 2. So let's find out where that is. And remember, the axis of symmetry is where the h or the x coordinate, so the vertex in this case would be hk. So when you average your zeros, you're basically figuring out the h. What is the x coordinate of the vertex? So h will equal 2 plus negative 1/3 divided by 2. That's an average. Add them up and divide by 2. And I'll let you do the math, but I believe that this turns out to be 5/6. And then to get the k is the y-coordinate of the vertex. So we know that this is happening at 5/6. And now what we need to do is substitute the 5/6 back into the equation, either this form of the equation, or it's actually maybe a little easier to put it in this form of the equation, and solve for y. So k will equal y when x equals 5/6. Okay, so 5/6 minus 2, that equals negative 7/6. And then 3 times 5/6, 3 and 6 will cancel. That'll give you a 2. So 5/2 plus 1. 1 is the same as 2/2, so that's 5/2 plus 2/2, which is 7/2. And so that equals negative 49/12 would be the k value, or the y coordinate of the vertex. And so you get a final equation of y equals, what's a? A is equal to 3, x minus 5/6 squared minus 49/12. Okay, so we now have all three versions of this equation. We started out with standard form, which was y equals 3x squared minus 5x minus 2. We turned that into factored form, which is y equals x minus 2, 3x plus 1. And just notice that the way that this works is that I could factor this 3 out of this bracket, and that would become y equals 3, x minus 2, x plus 1/3. So I'm basically just dividing each of these two terms by 3. So there's one x-intercept and there's the other x-intercept. Okay? And so that's kind of what I was talking about here. This gets to be really complicated. That's why it can be just written just like this one here. Because we could take something where there is a coefficient on one of the x's or both of the x's, and that number can get factored out. So anyway, that's just an aside, and don't worry about that if you're not really getting that. But and so then finally, so this is your vertex, this is your standard, and then this one would be actually the fully simplified factored version. But if you were doing this for me, this version here would be just fine. I just wanted to show you that even though it doesn't look like there's an A value here, there really is. It's just sitting inside this bracket, okay? Because I did say earlier that the A value stays the same. Okay, so that's what we've done in the past when it is factorable. But here's the next question right here. What do we do if the equation is not factorable? How do we deal with that? How do we figure out what the vertex is of a quadratic relation that is not factorable? So let's take a look. There are actually two ways to do this. The first one is through a method called partial factoring. So here's an example of partial factoring. So we have this equation, y equals 3x squared minus 6x plus 5. Oh, by the way, partial factoring works for every parabola because partial factoring will tell you where that vertex is occurring, and every parabola has a vertex. Factoring is the one that doesn't work all the time. But these two methods that I'm going to do today, they work all the time. You can get to the vertex all the time using either one of these two methods. They both always work. Okay, so this is the graph of that equation, and you can see that there are no x-intercepts here, which means this wasn't factorable, which means we couldn't have done it that way. So partial factoring says do this. Step number one is factor the quadratic, actually common factor I should say, common factor the quadratic and linear term. So basically in y equals ax squared plus bx plus c, ax squared is your quadratic term and bx is your linear term. So you are common factoring these two terms. All right, that's step number one. So in our question, which I will do in black, in our question, we have 3x squared minus 6x plus 5. We want to common factor those two terms. So that gives us 3x and x minus 2. The plus 5 is going to hang on to the end. All right, now what we want to do is only look at these two terms right here. So, and we want to look at where does that equal 0? I know it seems weird. It's not that the whole thing is equaling 0. So basically, if this equals 0, this stuff in purple here, if it equals 0, and this is y equals that, then we are actually technically trying to figure out when y equals 0 plus 5, which technically we're looking at when does y equal 5? Well, 5 is right here. That's 5. That's where y equals 5. So it's going to equal 5 there, and it's going to equal 5 over here. And because of the symmetric nature of a parabola, the axis of symmetry is going to be directly in between those two values, or between these two x values, between this one and this one. Because for any point on the parabola, let's say when y equals 8, that's here and that's here. The axis of symmetry is directly in between, and we know that the vertex is on the axis of symmetry. When does y equal 10? Well, it equals 10 here and it equals 10 over here, and the axis of symmetry is exactly between those two. So we are actually trying to solve when does 3x times x minus 2 equal 0. So that partially factored part, well, it's going to equal 0 when 3x equals 0, which means x equals 0. And it's going to equal 0 when x minus 2 equals 0, or when x equals 2. So these aren't the zeros of the parabola, but they are the zeros of the partially factored part. And so then we take and we do what we did before. We average those. That'll give us the axis of symmetry, which is the h coordinate of the vertex. So h equals 0 plus 2 over 2, which is going to equal 1. And then k, you take that h value, it equals, and you can use either version. I'm going to use 3x times x minus 2 plus 5. Let me just take that k out of there. And so when x equals 1, so it's 3 times negative 1 plus 5, which is equal to 2. So then that means that the vertex is at 1, 2. So vertex form, you're going to have the same a value, which is 3, x minus 1 squared plus 2. All right? So it's almost exactly the same as before, except a whole lot easier, because you don't have to think, okay, well, what two numbers multiply to give us this and add to give us this? And that's not even possible for this question. Like if I tried to do that here, what two numbers multiply to give us 15 and add to give us negative 6? There aren't any. There are no numbers that do that. I mean, there are numbers that do that, but there aren't friendly numbers that do that. Actually, I lied. There are no numbers that do that. This is not factorable because it doesn't have any x-intercepts. Okay, so let's try another one. I'll get you started on this one just because the partial factoring part might be a little confusing because you are factoring out that negative 0.5 there. But then after I'm done, I want you to stop the video, complete it, and then come back and check to see what your answer is. If you think you can start right from scratch, then go ahead. So remember, we are just partially factoring these two. So 0.5x squared plus 2x plus 4. I've talked about factoring before when you have a fraction or a decimal and you want to factor that decimal out. I mean, you don't have to, but it makes it a little bit easier. So we're taking out a negative 0.5x. You should always have an x here because the first two terms will always share an x because the first one has an x squared and the next one has an x. And then what you do with that coefficient is up to you. You can leave it in the bracket. You can take it out of the bracket. It really doesn't matter. I'll show you both versions. So then I'll be left with an x, and then 2 divided by negative 0.5 is equal to minus 4. Check on your calculator if you don't believe me. You're doing 2 divided by a half. How many times does a half go into 2? Not 2 divided by 2. So that's x minus 4, and then plus 4. This first one will tell you that x equals 0, and the second one will tell you that x equals 4. So 0 and 4, if I'm going to draw this, remember the y value in this case is 4. So that's going to be 0. One of them is always going to be on your x-axis, so that will be your your y-intercept. And then the other one is over here at 4. So we know that the axis of symmetry is going to sit right in between those two. So h is going to equal 0 plus 4 over 2, which is equal to 2. So that's the x-coordinate of the vertex, or it is the axis of symmetry. And k will equal k will equal negative 0.5 times 2 times 2 minus 4 plus 4. Negative 0.5 times 2 is negative 1. 2 minus 4 is negative 2. And that should be 6. So that is where our vertex is. So this parabola looks like this. It opens down because the a value is negative. We knew that. There are x-intercepts here, but they're not friendly x-intercepts. You would be trying to look for two numbers that multiply to give you 4 times negative 0.5, which is equal to negative 2, and add to give you 2. Those aren't friendly. We can't figure those out. So these are not friendly x-intercepts. So we don't even try to factor it. And so then that means that your equation is y equals, the a value is negative 0.5. The vertex, if this is h and this is k, that's at 2, 6. So that's x minus 2 squared plus 6. And that's it. I'm going to stop this video and I'm going to do the other method in another video.